Oh boy, oh boy, oh boy, another unboxing. So today we have the structure sensor, which will allow us to capture the world in 3D. You can see that it's made for the iPad mini, the iPad Air, and the iPad 4th generation. But what we're going to do is hook it up to a Jetson TK1. Let's take it out of the box and see what we have. Ooh, instructions apparently. It's always good. Getting started. More information. Oh, it's a laser product. That's good. We like lasers. So what's in the box? This looks important. Tiny little screwdriver. Appears to be a cable of some sort. Oh, this goes as a lightning connector for a iPad. And this must be where you plug it into the sensor. We don't care about that. A little wall wart. Place to plug it in. Some really tiny screws. That's for attaching it to your iPad, I assume. And then we have the structure sensor itself. It's a Class 1 laser product designed by Occipital, assembled in China. There's a little protective film. There we go. So it looks like we have a IR emitters, and that must be the receiver, the IR sensor. Kind of give you a sense of scale. This is in comparison to the Jetson board. It's a little bit smaller than the width of the board. Let's also compare it to a Kinect sensor. So here's the original Xbox 360 sensor. And here's the structure sensor. You can see this one's significantly smaller. Let's talk about what this one has and what this one does not have. This one has an RGB camera in it, as well as a IR projector and an IR sensor. It also has an array of microphones and a motor to actually tilt the device up and down, whereas the structure sensor is strictly just a depth camera. So it has, this appears to be the laser projector, and this is the IR sensor. So the key to this is that we've acquired a structure sensor hacker cable. So I liked it because it had the word hacker in it. So open that up, and you'll see that this cable has a USB end and then a connector to actually plug into the structure. So it goes like this. And we should be good to go to hook it into the Jetson. So let's install this baby and fire it up. Standard installation tools, a couple of paws, fire extinguisher. I would guess that we might have to charge the battery. So in that case, we would plug the power supply in here, but we'll just plug it straight into the hub and see what happens. First start. Let's see, we grab it, put it over here. Take the USB plug and plug it in. Oh, power light. It's a good sign. Now we're going to fire the Jetson up. Hit the button max. And it appears to have booted up. No fire. Excellent. So this has the same issue that Kinect has. You have to reconnect the USB after it's booted up. Here we go. So let's test her out. So I just placed the structure sensor on top of the monitor, and I went off and compiled OpenNI2. So we run a simple reader, and you can see that we get values out of the camera. Just wave our hands and get different values. Then we'll run an iViewer, which is kind of a graphical demo. Now, you never want to get excited about acquiring new hardware and getting it to work, especially when you're giving your demos. You want a professional level of demonstration that people can relate to. You never want to use garish colors. You want to keep the movement in the video smooth, fluid. You kind of want to avoid being spastic or just non-continuous types of motion. I learned all this from the Muppets, so I know it to be true. This uses a PrimeSense chipset. It's basically the same sensor that was in the Xbox 360 Kinect. As such, it has the same types of settings, different sizes of sensor capture, things like that. It's my understanding that it also has an active IR element, which is a little bit different than the original Kinects. I haven't figured out how to turn that on and off yet, though. Different capture size, different rates. Depth is about 640 by 480 at 30 frames a second, as is the IR. IR stream's a little bit bigger. Oh, time to go. Bye.